All right, what I would like to do is, we do have a little bit of time prior to the assembly here. So I want to just remind you about some stuff about vector addition, because you guys are sort of getting short-changed on a class here a little bit. And I do have my afternoon class that is going to do this, okay? So you are sort of missing out a little bit. So I would like to quickly, if I could, those of you that actually brought books today, if you could get that out. And let's quickly look at those practice problems from yesterday. We did 1 and 2, and then did I ask you to do 3 and 4? How did we end up? Did you? Okay, well, let's have a quick look at number 3 and 4 here. We got a hunter walking 4.5 kilometers east, making a 45-degree right to the turn, and then another 6.4 kilometers. And I do sort of kind of remember doing this with you. So that would be 45 degrees. I'm just going to sketch here, right? And then the resultant would be from there to there. Now remember, you can't use Pythagoras on this. How come? Not a right triangle. How many people are going to try using Pythagoras on a non-right triangle on the test? Don't put your hand up and don't do it. Don't do it. You can't do it. You need a ruler and a protractor. Okay? And your answer there should have been 10.2 kilometers, and the bearing is, yes, I did this with you guys yesterday, east 27 south. I remember doing it. Right? You need a ruler and a protractor for that. Now, number 4, I don't think I did. Let's have a quick look at number 4. You follow directions that tell you walk 225 meters south, and you would do this by scale. You would write 1 centimeter equals. Remember, you always start your scale with 1 centimeter equals. We got 225, we got 350, and we got 125. So what would you go with? Maybe 25 or even 50 meters? I'm thinking 50. 50 meters. So we would go 225 south, and a 90-degree turn to the left. So if you're going this way, turning to the left would be like this, right? And we're going to go 350. And then a 30-degree turn to the left and 125. So 30 degrees in there, right? Okay. When you add vectors, you always place them? Tip to tail would be the better way to say it. Tip to tail, right? And your resultant is always from where to where? From the start to where you ended up. That is always the resultant, right? Always, always, always. What angle do I measure there? You would be measuring this one here, likely from south, right? From south. Okay, you always have to measure an angle from north, from south, from east, or from west. Okay, and so that answer there would be, I did 1 centimeter equals 50 kilometers. I measured my resultant to be 9.8 centimeters. How do I convert the 9.8 centimeters to meters? Luke? Yep, like from bearing? Yep, as long as you're measuring from north. Yep, absolutely. Although it's kind of convention that if it's given in one way in the question, you kind of give it back the same way, but yeah, that's okay. All right, so 9.8. How do I get it to meters? I would times by 50, and I would get a resultant of 490 kilometers. I'm measuring this angle in here, and in that I get south 72 east. You're right. I've got kilometers on mine, but you're right, it is. I probably made that mistake many years in a row. Okay, relatively easy. What do you think? Not terribly hard, yet I still know that people need to practice because I see it from year to year where they mess up in little places. So I'm going to give you, I know there's not a lot of time left, but I've handed this out here. Okay, so it says problems, vector addition, problems, subtraction vectors. Do not do subtraction. Subtraction is a little more harder than you think. Okay, I just saving paper, that's all. Okay, so I'm assigning for the weekend those 6 addition questions. You'll notice that I've conveniently provided the solution for you. So there's no excuse for I didn't know how to do it. It's right there. If the only thing you can do is copy, do that. By the time you've copied it out 6 times, you'll have gotten it. You'll get it. Okay? Don't just sit back and say, oh, I don't get it. It's right there. All right?